Okay, so question number 11. What is the Lewis structure for sulfur dibromide? So first, let's find the total number of valence electrons for this compound. So we have sulfur, which contains 6 valence electrons, and we have bromine, which contains 7. And there are 2 bromine atoms, so we multiply this by 2. And we get a total of 20 valence electrons. So now we draw sulfur as our central atom and 2 single bonds to our bromines. Now we can draw in all the lone pairs and then count out how many electrons I've drawn so far. So each bond contains 2 bonding electrons, and each bromine has the 6 electrons as lone pairs. So far we only have 16 electrons in this structure, and I need 20 in total. So I'm just going to draw 4 more on my central sulfur atom. So now we have a valid Lewis structure for sulfur bromide, or dibromide. And the junior tutor said that a Lewis dot structure is a representation of an atom, ion, or compound that shows how the valence electrons of the atoms are distributed as bonds, lone pairs, and sometimes radicals. Okay, so they have a nice step-by-step guide and also some rules. So there are no formal charges on our compound, but basically you want to make sure that the sum of the formal charges would match the charge of the compound. Okay, so now they've used these guides in drawing the Lewis structure. Sulfur would be the more logical central atom because it will typically create more bonds since it has fewer valence electrons. The arrangement will be sulfur surrounded by the 2 bromines. They drew in all of the lone pairs. And they also showed how one would solve for formal charge. But this rule is not applicable since all the formal charges would be 0. Okay, so they got the correct answer. So this solution is correct.